Determining the correct ampacity for THHN conductors using National Electrical Code Table 310.16 involves understanding when to use the 75°C column and when to use the 90°C column. The choice depends primarily on how the conductors are installed. National Electrical Code Section 310.16 states that the allowable ampacity of conductors not installed in raceways, cable trays, or cable shall be determined from the 75°C conductor temperature column of Table 310.16. This means that if a THHN conductor is run in free air, without being enclosed in a raceway, cable tray, or cable bus, its ampacity must be determined based on the 75°C column. The reasoning behind this is that conductors run in ambient temperatures above 40°C, which is 104°F, typically have reduced ampacity due to increased conductor resistance. In other words, the higher the temperature of the conductor, the less current it can safely carry without overheating and potentially damaging the insulation or creating a fire hazard. The 75°C column provides a more conservative ampacity rating, ensuring that the conductors do not overheat in extreme ambient temperatures. This is a safety measure to account for situations where the surrounding environment is already hot, and the conductor's own heat generation from carrying current could push it beyond its safe operating temperature. On the other hand, National Electrical Code Section 310.16b3 states that where conductors are installed in raceways, cable trays, or cable bus, the allowable ampacity shall be determined from the 90°C conductor temperature column of Table 310.16. This means that if a THHN conductor is enclosed in a raceway, cable tray, or cable bus, its ampacity can be determined based on the 90°C column. The reasoning here is that raceways, cable trays, and cable bus provide additional protection for the conductors, allowing for higher operating temperatures. These enclosures help to dissipate heat and protect the conductors from physical damage and environmental factors. However, it is important to note that even when using the 90°C column, care should be taken to ensure that the ambient temperature inside the enclosure does not exceed 40°C, which is 104°F. If the ambient temperature inside the enclosure is higher than this, the ampacity of the conductors must be derated accordingly. Derating involves reducing the allowable ampacity of the conductors to account for the higher ambient temperature. This is done to prevent the conductors from overheating and potentially causing a fire hazard. The National Electrical Code provides tables and guidelines for derating conductors based on ambient temperature and the number of conductors in a raceway or cable. In summary, use the 75°C column for conductors not installed in raceways, cable trays, or cable bus, and use the 90°C column for conductors installed in raceways, cable trays, or cable bus. The 75°C column provides a more conservative ampacity rating, ensuring that the conductors do not overheat in extreme ambient temperatures. The 90°C column allows for a slightly higher ampacity rating as the conductors are protected by the enclosure. However, it is crucial to ensure that the ambient temperature inside the enclosure does not exceed 40°C, which is 104°F. It's also important to understand the purpose of the THHN insulation rating itself. THHN stands for thermoplastic high heat resistant nylon. This means the conductor insulation is made of a thermoplastic material that is resistant to high temperatures and has a nylon jacket for added protection against abrasion and chemicals. The H in THHN indicates that the insulation is heat resistant to 75°C in a wet location and 90°C in a dry location. This is why the 75 and 90°C columns are relevant when determining the ampacity of THHN conductors. The nylon jacket also provides mechanical protection, making THHN conductors suitable for use in raceways where they may be subjected to pulling and abrasion during installation. However, even with the nylon jacket, it's important to follow proper installation practices to avoid damaging the insulation. When pulling THHN conductors through raceways, use a pulling lubricant to reduce friction and prevent the insulation from being scraped or torn. Also, avoid exceeding the maximum pulling tension recommended by the conductor manufacturer. In addition to ambient temperature, The number of conductors in a raceway or cable also affects the ampacity of the conductors. When multiple current-carrying conductors are installed in close proximity, the heat generated by each conductor can raise the overall temperature inside the raceway or cable. This increased temperature reduces the ability of the conductors to dissipate heat, which in turn reduces their ampacity. The National Electrical Code provides tables and guidelines for directing conductors based on the number of current-carrying conductors in a raceway or cable. These directing factors are applied to the allowable ampacity of the conductors to ensure that they do not overheat. For example, if there are more than 3 current-carrying conductors in a raceway, the ampacity of each conductor must be reduced by a certain percentage depending on the number of conductors. This directing factor can range from 70% to 40% depending on the number of conductors. It's important to note that equipment grounding conductors and bonding conductors are not considered current-carrying conductors for the purpose of ampacity directing. This is because these conductors are only intended to carry current during a fault condition such as a short circuit or ground fault. Neutral conductors are also generally not considered current-carrying conductors unless they carry a significant amount of unbalanced current. In a three-phase system, the neutral conductor only carries the difference between the currents in the three-phase conductors. If the load is balanced, the neutral current will be zero. However, in a single-phase system, the neutral conductor carries the same amount of current as the phase conductor and is therefore considered a current-carrying conductor. When directing conductors for the number of current-carrying conductors, it's important to consider all of the conductors in the raceway or cable, including spares. Even if a conductor is not currently being used, it can still contribute to the overall heat generated inside the raceway or cable. Therefore, it's important to include spare conductors when calculating the directing factor. In addition to ampacity directing, it's also important to consider voltage drop when sizing conductors. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to the resistance of the conductor. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends that the voltage drop on branch circuits should not exceed 3% and the voltage drop on feeders should not exceed 5%. To calculate the voltage drop on a conductor, you need to know the length of the conductor, the current flowing through the conductor, and the resistance of the conductor. The resistance of the conductor depends on the material of the conductor, its cross-sectional area, and its temperature. The National Electrical Code provides tables and formulas for calculating voltage drop. To minimize voltage drop, you can use larger conductors, which have lower resistance, or you can shorten the length of the conductors. You can also use conductors with a higher conductivity, such as copper instead of aluminum. When selecting conductors, it's important to consider not only the ampacity requirements but also the voltage drop requirements. You may need to use larger conductors than required by the ampacity tables to meet the voltage drop limits. In addition to THHN conductors, there are other types of conductors that are commonly used in electrical wiring. Some of these include THW, THWN, SHHW, and use conductors. THW conductors are similar to THHN conductors but are only rated for 75 degrees Celsius in both wet and dry locations. THWN conductors are similar to THW conductors but have a nylon jacket for added protection against abrasion and chemicals. XHHW conductors are cross-linked polyethylene insulated conductors that are rated for 90 degrees Celsius in both wet and dry locations. Use conductors are underground service entrance conductors that are designed for direct burial in the ground. The choice of which type of conductor to use depends on the specific application and the environmental conditions. For example, use conductors are typically used for underground service entrances, while THHN conductors are commonly used for general wiring in raceways. When installing conductors, it's important to follow all applicable codes and standards, including the National Electrical Code and local building codes. These codes and standards provide detailed requirements for the installation of electrical wiring, including conductor sizing, ampacity directing, voltage drop, and grounding. It's also important to use proper wiring techniques and tools to ensure that the conductors are installed safely and reliably. This includes using proper connectors, crimping tools, and wire strippers. It's also important to avoid damaging the insulation of the conductors during installation. Damaged insulation can create a shock hazard or a fire hazard. If you are not familiar with electrical wiring practices, it's best to hire a qualified electrician to do the work. Electrical wiring can be dangerous if not done properly. A qualified electrician has the knowledge, skills, and experience to install electrical wiring safely and in accordance with all applicable codes and standards. They can also help you select the right type and size of conductors for your application and ensure that the wiring is properly grounded and protected. Grounding is an essential part of electrical safety. Grounding provides a low resistance path for fault current to flow back to the source, which helps to trip circuit breakers or fuses and prevent electrical shock. All electrical systems should be properly grounded in accordance with the National Electrical Code. The grounding system typically consists of a grounding electrode, such as a ground rod or a metal water pipe, and a grounding conductor that connects the grounding electrode to the electrical panel. All metal enclosures and equipment should also be grounded to provide a path for fault current to flow back to the source. In addition to grounding, overcurrent protection is also essential for electrical safety. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overload and short circuits. When an overcurrent occurs, the overcurrent protection device will trip or blow, interrupting the flow of current and preventing damage to the electrical system. It's important to select the correct size overcurrent protection device for the circuit. The size of the overcurrent protection device should be based on the ampacity of the conductors and the load being served. The National Electrical Code provides guidelines for selecting the correct size overcurrent protection device. It's also important to ensure that the overcurrent protection devices are properly installed and maintained. Circuit breakers should be tested periodically to ensure that they are functioning properly. Fuses should be replaced when they blow. Electrical wiring is a complex and potentially dangerous field. It's important to have a thorough understanding of electrical codes, standards, and practices before attempting to do any electrical work. If you are not familiar with electrical wiring, it's best to hire a qualified electrician to do the work. A qualified electrician can ensure that the wiring is installed safely and in accordance with all applicable codes and standards. Remember to always prioritize safety when working with electricity. Always turn off the power before working on any electrical circuits. Use proper safety equipment, such as insulated gloves and safety glasses. And never work on electrical circuits when you are wet or tired. By following these safety precautions, you can help to prevent electrical shocks and fires. When working with THHN conductors, it's important to be aware of the different colors that are used to identify the different conductors. The National Electrical Code specifies a color code for electrical wiring. The color code helps to ensure that the wiring is installed correctly and that the circuits are properly identified. The most common colors used in electrical wiring are black, red, blue, white, and green. Black wires are typically used for hot conductors in 120-volt circuits. Red wires are typically used for hot conductors in 240-volt circuits or as the second hot wire in a 120-volt circuit. Blue wires are typically used for hot conductors in three-phase circuits. White wires are typically used for neutral conductors. Green wires are typically used for grounding conductors. It's important to follow the color code when wiring electrical circuits. This will help to ensure that the circuits are properly identified and that the wiring is installed safely. It's also important to label the circuits in the electrical panel so that they can be easily identified. Labeling the circuits will help to prevent confusion and make it easier to troubleshoot problems. When working with electrical wiring, it's important to use the right tools for the job. Using the wrong tools can damage the wiring or create a safety hazard. Some of the essential tools for electrical wiring include wire strippers, wire cutters, crimpers, pliers, screwdrivers, and a voltage tester. Wire strippers are used to remove the insulation from the conductors. Wire cutters are used to cut the conductors to the desired length. Crimpers are used to crimp connectors onto the conductors. Pliers are used to grip and manipulate the conductors. Screwdrivers are used to tighten and loosen screws. A voltage tester is used to check for voltage in the circuit before working on it. Before starting any electrical work, it's important to turn off the power to the circuit at the electrical panel. This will help to prevent electrical shock. Use a voltage tester to verify that the power is off before touching any of the wires. Once the power is off, you can begin working on the circuit. Be sure to follow all applicable codes and standards when wiring the circuit, and always double check your work before turning the power back on. If you are not comfortable working with electrical wiring, it's best to hire a qualified electrician to do the work. Electrical wiring can be dangerous if not done properly. A qualified electrician has the knowledge, skills, and experience to install electrical wiring safely and in accordance with all applicable codes and standards. In conclusion, understanding the 75 degrees Celsius and 90 degrees Celsius columns in National Electrical Code Table 310.16 is crucial for correctly determining the ampacity of THHN conductors. Installation method, ambient temperature, and number of conductors all play a significant role in selecting the appropriate ampacity. Always adhere to the National Electrical Code and local building codes to ensure electrical safety and proper wiring practices.